In this video, I want to give you the basics of trigonometry. Trigonometry. And it sounds like a very complicated topic, but you're going to see that it's really just the study of the ratios of sides of triangles. The trig part of trigonometry literally means triangle, and the metry part literally means measure. So let me just give you some examples here, and I think it'll make everything pretty clear. So let me draw some right triangles. Let me just draw one right triangle. So this is a right triangle. And when I say it's a right triangle, it's because one of the angles here is 90 degrees. This right here is a right. That right there is a right angle. It is equal to 90. It is equal to 90 degrees. And we'll talk about other ways to show the magnitude of angles in future videos. So we have a 90-degree angle. It's a right triangle. Let me put some lengths to the sides here. So this side over here is maybe 3. This height right over there is 3. Maybe the base of the triangle right over here is 4. And then the hypotenuse of the triangle. The hypotenuse of the triangle over here is 5. You only have a hypotenuse when you have a right triangle. It is the side opposite the right angle, and it is the longest side of a right triangle. So that right there is the hypotenuse. Hypotenuse. You probably learned that already from geometry. And you can verify that this right triangle, the sides work out. We know from the Pythagorean theorem that 3 squared plus 4 squared has got to be equal to the length of the longest side. The length of the hypotenuse squared is equal to 5 squared. So you can verify that this works out. This satisfies the Pythagorean theorem. Now, with that out of the way, let's learn a little bit of trigonometry. So the core functions of trigonometry, we're going to learn a little bit more about what these functions mean. There is the sine function. There is the cosine function. And there is the tangent function. And you write sine, cos, or sin, COS, and tan for short. And these really just specify for any angle in this triangle, it'll specify the ratios of certain sides. So let me just write something out. And this is a little bit of a mnemonic here. So something just to help you remember the definitions of these functions. But I'm going to write down something. It's called TOA. TOA. And you'll be amazed how far this mnemonic will take you in trigonometry. So we have TOA. And what this tells us is, so tells us that sine is equal to opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. It's telling us. And this won't make a lot of sense just yet. I'll do it a little bit more detail in a second. And then cosine is equal to adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then you finally have tangent. You have tangent. Tangent is equal to opposite over adjacent. Opposite over adjacent. So you're probably saying, hey, Sal, what is this, all this opposite, hypotenuse, adjacent? What are we talking about? Well, let's take an angle here. Let's take an angle here. Let's say that this angle right over here. This angle right over here is theta, between the side of length 4 and the side of length 5. This angle right here is theta. So let's figure out what the sine of theta, the cosine of theta, and what the tangent of theta are. So if we want to first focus on the sine of theta, we just have to remember SOH. SOH. Sine is opposite over hypotenuse. So sine of theta is equal to the opposite. So what's the opposite side to the angle? So this is our angle right here. The opposite side, if you just go the opposite side, so not one of the sides that are kind of adjacent to the angle, the opposite side is the 3. If you're just it's opening onto that 3. So the opposite side is 3. And then what's the hypotenuse? The hypotenuse, well, we already know the hypotenuse here is 5. So it's 3 over 5. The sine of theta is 3/5. So someone says, hey, what's the sine of that? It's 3/5. And I'm going to show you in a second that the sine of theta if this angle is a certain angle, it's always going to be 3/5. The ratio of the opposite to the hypotenuse is always going to be the same, even if the actual triangle were a larger triangle or a smaller one. So I'll show you that in a second. But let's go through all of the trig functions. Let's think about what the cosine. Let's think about what the cosine of theta is. Cosine is adjacent over hypotenuse. So remember, let me label them. We already figured out that the 3 was the opposite side. This is the opposite side. And only when we're talking about this angle. When you talk about this angle, this side is opposite to it. When you talk about this angle, this 4 side is adjacent to it. It's one of the sides that kind of make up that kind of form the vertex here. So this right here is an adjacent side. Adjacent. And I want to be very clear. This only applies to this angle. If we were talking about that angle, then this green side would be opposite, and this yellow side would be adjacent. But we're just focusing on this angle right over here. So cosine of this angle, we hear about adjacent. Well, the adjacent side to this angle is 4. So it is adjacent over the hypotenuse. It's the adjacent, which is 4, over the hypotenuse. 4 over 5. Now let's do the tangent. Let's do the tangent. The tangent of theta. Opposite over adjacent. The opposite side is 3. The opposite side is 3. What is the adjacent side? We already figured that out. The adjacent side is 4. So knowing the sides of this right triangle, we were able to figure out the major trig ratios. And we'll see there are other trig ratios, but they can all be derived from these 3 basic trig functions. Now, let's think about another angle in this triangle. And I'll redraw it just because my triangle is getting a little bit messy. So let's redraw the exact same triangle. The exact same triangle. And once again, the lengths of this triangle are, we have length 4 there. We have length 3 there. And we have length 5 there. The last example, we used this theta. But let's do another angle. Let's do another angle up here. Let's do another angle up here. And let's call this angle, I don't know, I'll think of something, a random Greek letter. So let's say it's xi. I know it's a little bit bizarre. Theta is what you normally use, but since I already used theta, let's use xi. Actually, even instead of xi, let me just simplify it. Let me call this angle x. Let's call that angle x. So let's figure out the trig functions for that angle x. So we have sine of x is going to be equal to what? Well, sine is opposite over hypotenuse. So what side is opposite to x? Well, it opens onto this 4. It opens onto the 4. So in this context, this is now the opposite. This is now the opposite side. Remember, 4 was adjacent to this theta, but it's opposite to x. So it's going to be 4 over, now what's the hypotenuse? Well, the hypotenuse is going to be the same regardless of which angle you pick. So the hypotenuse is now going to be 5. So it's 4/5. Now let's do another one. What is the cosine? What is the cosine of x? So cosine is adjacent over hypotenuse. What side is adjacent to x? That's not the hypotenuse. You have the hypotenuse here. Well, the 3 side. It's one of the sides that forms the vertex that x is at, and it's not the hypotenuse, so this is the adjacent side. That is adjacent. So it's equal to 3 over the hypotenuse. The hypotenuse is 5. And then finally, the tangent. We want to figure out the tangent of x. Tangent is opposite over adjacent. So TOA. Tangent is opposite over adjacent. Opposite over adjacent. The opposite side is 4. I want to do it in that blue color. The opposite side is 4. And the adjacent side is 3. And we're done. In the next video, I'll do a ton of more examples of this, just so we really get a feel for it. But I'll leave you thinking about what happens when these angles start to approach 90 degrees, or how could they even get larger than 90 degrees. And what we're going to see is that this definition, the SOH-TOA definition, takes us a long way for angles that are between 0 and 90 degrees, or that are less than 90 degrees. But they kind of start to mess up really at the boundaries. And we're going to introduce a new definition that's kind of derived from the SOH-TOA definition for finding the sine, cosine, and tangent of really any angle. Let's just do a ton of more examples just so that we make sure that we're getting this trig function thing down well. So let's construct ourselves some right triangles. Let's construct ourselves some right triangles. And I want to be very clear. The way I've defined it so far, this will only work in right triangles. So if you're trying to find the trig functions of angles that aren't part of right triangles, we're going to see that we're going to have to construct right triangles. But let's just focus on the right triangles for now. So let's say that I have a triangle where, let's say this length down here is 7. And let's say the length of this side up here, let's say that that is 4. And let's figure out what the hypotenuse over here is going to be. So we know, let's call the hypotenuse h. We know that h squared is going to be equal to 7 squared plus 4 squared. We know that from the Pythagorean theorem, that the hypotenuse squared is equal to the square of each of the sum of the squares of the other two sides. H squared is equal to 7 squared plus 4 squared. So this is equal to 49 plus 16. 49 plus 16. Let's see, 49 plus 10 is 59. Plus 6 is 65. It is 65. So this h squared, let me write h squared. It's a different shade of yellow. So we have h squared is equal to 65. Did I do that right? 49 plus 10 is 59, plus another 6 is 65. Or we could say that h is equal to, if we take the square root of both sides, square root of 65. And we really can't simplify this at all. This is 13. This is the same thing as 13 times 5. Both of those are not perfect squares, and they're both prime, so you can't simplify this anymore. So this is equal to the square root of 65. Now let's find the trig. Let's find the trig functions for this angle up here. Let's call that angle up there theta. So whenever you do it, you always want to write down, at least for me it works out to write down, SOH. SOH. I have these vague memories of my trigonometry teacher. Maybe I read it in some book. I don't know, about some type of Indian princess named SOH or whatever. But it's a very useful mnemonic. So we can apply SOH. Let's say we wanted to find the cosine. We want to find the cosine of our angle. We want to find the cosine of our angle. You say SOH. So the ka tells us what to do with cosine. The ka part tells us that cosine is adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. So let's look over here. To theta, what side is adjacent? Well, we know that the hypotenuse is this side over here. So it can't be that side. The only other side that's kind of adjacent to it, that isn't the hypotenuse, is this 4. So the adjacent side over here, that side it's literally right next to the angle. It's one of the sides that kind of forms the angle. It's 4 over the hypotenuse. The hypotenuse, we already know, is square root of 65. So it's 4 over the square root of 65. And sometimes people will want you to rationalize the denominator, which means they don't like to have an irrational number in the denominator, like the square root of 65. And if you want to rewrite this without a irrational number in the denominator, you can multiply the numerator and the denominator by square root of 65. This clearly will not change the number, because we're multiplying it by something over itself. So we're multiplying the number by 1. That won't change the number, but at least it gets rid of the irrational number in the denominator. So the numerator becomes 4 times the square root of 65. And the denominator, square root of 65 times square root of 65, is just going to be 65. We didn't get rid of the irrational number. It's still there, but it's now in the numerator. Now let's do the other trig functions, or at least the other core trig functions. We'll learn in the future that there's actually a ton of them, but they're all derived from these. So let's think about what the sine of theta is. Once again, go to SOH. The SO tells us what to do with sine. Sine is opposite over hypotenuse. Sine is equal to opposite over hypotenuse. Sine is opposite over hypotenuse. So for this angle, what side is opposite? Well, you just go opposite it, what it opens into. It's opposite the 7. So the opposite side is the 7. This is right here. That is the opposite side. And then the hypotenuse. It's opposite over hypotenuse. The hypotenuse is the square root of 65. Square root of 65. And once again, if we wanted to rationalize this, we could multiply it times the square root of 65 over the square root of 65. In the numerator, we'll get 7 square roots of 65. And in the denominator, we will get just 65 again. Now let's do tangent. Let us do tangent. So if I asked you the tangent of theta, once again, go back to SOH, TOA. The TOA part tells us what to do with tangent. It tells us that tangent is equal to opposite over adjacent, is equal to opposite over adjacent. So for this angle, what is opposite? We've already figured it out. It's 7. It opens into the 7. It's opposite the 7. So it's 7 over what side is adjacent? Well, this 4 is adjacent. This 4 is adjacent. So the adjacent side is 4. So it's 7 over 4. And we're done. We figured out all of the trig ratios for theta. Let's do another one. Let's do another one. I'll make it a little bit concrete. Because right now we've been saying, oh, what's tangent of x? What's tangent of theta? Let's make it a little bit more concrete. Let's say, let me draw another right triangle. Another right triangle here. Everything we're dealing with, these are going to be right triangles. Let's say the hypotenuse has length 4. Let's say that this side over here has length 2. And let's say that this length over here is going to be 2 times the square root of 3. We can verify that this works. If you have this side squared, so you have, let me write it down, 2 times the square root of 3 squared plus 2 squared is equal to what? This is 2. This is going to be 4 times 3. 4 times 3 plus 4. And this is going to be equal to 12 plus 4 is equal to 16. And 16 is indeed 4 squared. So this does equal 4 squared. It does equal 4 squared. It satisfies the Pythagorean theorem. And if you remember some of your work from 30, 60, 90 triangles that you might have learned in geometry, you might recognize that this is a 30, 60, 90 triangle. This right here is our right angle. I should have drawn it from the get-go to show that this is a right triangle. This angle right over here is our 30-degree angle. And then this angle up here is a 60-degree angle. And it's a 30, 60, 90 because the side opposite the 30 degrees is half the hypotenuse. And then the side opposite the 60 degrees is a square root of 3 times the other side that's not the hypotenuse. So with that said, we're not going to, this isn't supposed to be a review of 30, 60, 90 triangles, although I just did it. Let's actually find the trig ratios for the different angles. So if I were to ask you, or if anyone were to ask you, what is the sine of 30 degrees? And remember, 30 degrees is one of the angles in this triangle, but it would apply whenever you have a 30-degree angle and you're dealing with a right triangle. We'll have broader definitions in the future. But if you say sine of 30 degrees, hey, this angle right over here is 30 degrees, so I can use this right triangle. And we just have to remember SOH TOA. Let me rewrite it. SOH TOA. Sine tells us, SOH tells us what to do with sine. Sine is opposite over hypotenuse. Sine of 30 degrees is the opposite side. That is the opposite side, which is 2 over the hypotenuse. The hypotenuse here is 4. It is 2/4, which is the same thing as 1/2. Sine of 30 degrees, you'll see, is always going to be equal to 1/2. Now, what is the cosine? What is the cosine of 30 degrees? Once again, go back to SOH TOA. The ka tells us what to do with cosine. Cosine is adjacent over hypotenuse. So if we're looking at the 30-degree angle, it's the adjacent. This right over here is adjacent. It's right next to it. It's not the hypotenuse. It's the adjacent over the hypotenuse. So it's 2 square roots of 3 adjacent over the hypotenuse, over 4. Or if we simplify that, we divide the numerator and the denominator by 2. It's the square root of 3 over 2. Finally, let's do the tangent. The tangent of 30 degrees. We go back to SOH TOA. SOH TOA. TOA tells us what to do with tangent. It's opposite over adjacent. We go to the 30-degree angle, because that's what we care about. Tangent of 30. Tangent of 30. Opposite is 2. Opposite is 2, and the adjacent is 2 square roots of 3. It's right next to it. It's adjacent to it. Adjacent means next to. So 2 square roots of 3. So this is equal to, the 2's cancel out, 1 over the square root of 3. Or we can multiply the numerator and the denominator by the square root of 3. So we have square root of 3 over square root of 3. And so this is going to be equal to, the numerator is square root of 3, and then the denominator right over here is just going to be 3. So that's, we've rationalized it. Square root of 3 over 3. Fair enough. Now let's use the same triangle to figure out the trig ratios for the 60 degrees, since we've already drawn it. So what is the sine of 60 degrees? I think you're hopefully getting the hang of it now. Sine is opposite over adjacent. So, from the SOH TOA, for the 60-degree angle, what side is opposite? Well, it opens out into the 2 square roots of 3. So the opposite side is 2 square roots of 3. And from the 60-degree angle, it's opposite over hypotenuse. Don't want to confuse you. So it's opposite over hypotenuse. So it's 2 square roots of 3 over 4. 4 is the hypotenuse. So it is equal to, this simplifies to square root of 3 over 2. What is the cosine of 60 degrees? Cosine of 60 degrees. So remember, TOA, cosine is adjacent over hypotenuse. Adjacent is the 2 side. It's right next to the 60-degree angle. So it's 2 over the hypotenuse, which is 4. So this is equal to 1/2. And then finally, what is the tangent? What is the tangent of 60 degrees? Well, tangent, TOA, tangent is opposite over adjacent. Opposite the 60 degrees is 2 square roots of 3. 2 square roots of 3. And adjacent to that is 2. Adjacent to 60 degrees is 2. So it's opposite over adjacent. 2 square roots of 3 over 2, which is just equal to the square root of 3. And I just want to, look how these are related. The sine of 30 degrees is the same thing as the cosine of 60 degrees. The cosine of 30 degrees is the same thing as the sine of 60 degrees. And then these guys are the inverse of each other. And I think if you think a little bit about this triangle, it'll start to make sense why. We'll keep extending this and give you a lot more practice in the next few videos.